Alright, hello everyone. So let's solve this integral. Okay, so let's solve it using partial fraction decomposition. So if you look at the numerator, it's a fourth degree polynomial. If you look at the denominator, it's a third degree polynomial. So the numerator is larger in terms of the degree of the polynomial. So this is case 2. First we have to perform polynomial lone division. So let's perform the polynomial lone division. So we have to divide by x cube minus 3x minus 2. Okay. Alright, so we first compare the first two terms, x square, x to the power 4 and x cube. So to get x to the power 4, you have to multiply x cube by x. Now re-multiply. X times x cube is x to the 4, negative 3x square. So there's no x cube term. Okay, negative 3x square. Okay, x times negative 2x is negative 2x. Okay, perfect. Now you subtract. So if you subtract x square and x to the 4 and x to the 4 cancel out, x cube comes down, negative x square minus 3x square, this will become plus, so this is plus 2x square. 2x minus 2x is 4x, minus 1 comes for free. Now let's compare x cube and x cube. So to get x cube from x cube, you have to multiply by 1. So 1 times x cube is x cube, 1 times negative 3x is negative 3x, and there's no x square term. Okay, and 1 times negative 2 is negative 2. Now you subtract. If you subtract, these two cancel out. 2x square and 4x minus 3x is plus 7x. Okay, and then let's see, negative 1 minus 2 is plus 1. Okay, perfect. So now we have a second degree polynomial here and a third degree polynomial here. So device is larger than the remainder, so we stop here. Then the decomposition, the initial decomposition is quotient is x plus 1 plus the remainder is 2x square plus 7x plus 1 over the divisor is x cube minus 3x minus 2. Perfect. So this is the initial decomposition, right? Now we have a case 1 fraction, rational function. So we want to decompose that. Now to decompose that, we have to factor the denominator as much as possible. So let me give you the factors. Try to do it by yourself. So the factors are, let's see, x plus 1 square and x minus 2. So these are the factors. So this is a case 1 scenario. So if you write the decomposition, so it's going to be a over x plus 1. So this is a repeated linear factor, repeated twice. So b over x plus 1 square and plus c over x minus 2. So x minus 2 is not repeated. Okay, perfect. So that's the decomposition. Now we want to find a, b and c. So to find a, b and c, we can just use this part of the decomposition. So 2x square plus 7x plus 1 over x plus 1 square, x minus 2 is equal to a over x plus 1 plus b over x plus 1 square plus c over x minus 2. So to find a, b and c, we multiply both left hand side and right hand side by this big denominator. So on the left hand side, we will left it 2x square plus 7x plus 1. We have already done this a lot of times in our previous videos, right? So 1x plus 1 will be cancelled out. So 1x plus 1 will left and with a x minus 2. Here x plus 1 square will cancel out. So x minus 2 will remain. See here x minus 2 will cancel out. So x plus 1 square will remain. Alright, magic numbers. So let's use x is equal to 2 to find c, because then these two terms vanish, right? So when you substitute x is equal to 2, left hand side will be 2 square is 4. 4 times 2 is 8. 8 plus here 14 is 22, 23 on the left, right? So 2 plus 1 is 3. 3 square is 9, so 9c. So c is 23 over 9. Okay, perfect. Alright, so that does not look good. Okay, so to find, okay, so now we can use x is equal to negative 1 as the magic number. So this term and this term will vanish and we can find b. So if x is equal to negative 1, so here it will be 2 minus 7 is minus 5, minus 5 plus 1 is minus 4. This term will vanish when x is equal to negative 1. Negative 1 minus 3 is negative 3. So b is 4 over 3. Okay. Now we have to find a way to find a, because we ran out of magic numbers. So what can we do? Well, we can use an arbitrary number. So let's use x is equal to 0. So that's, I think, easier than expanding everything. So when x is equal to 0, left hand side is 1. Then a times, it's going to be negative 2, right, if you substitute 0. So negative 2a, negative 2b plus c, right? So we know b and c already. 1 negative 2a, negative 8 over 3 if you multiply b by negative 2, plus c is 23 over 9. Okay, so we can simplify these two numbers as 1 is equal to negative 2a. So here, if you make the denominator to become 9, it will be negative 24 plus 23 over 9. So it's negative 1 over 9. Okay, so 1 is equal to negative 2a, negative 1 over 9. So if you take 1 over 9 to the other side, it's going to be 10 over 9, right, over negative 2a. So a is negative 5 over 9. Okay, so we found a, b and c. All right, wow. Okay, so let's write the complete decomposition. So the complete decomposition for the rational function x cubed plus x to the 4 plus x cubed minus x square plus 2x minus 1 over x square x cube, minus 3x minus 2. So the complete decomposition for this is x plus 1 plus or minus a is 5 over 9 x plus 1 and b is plus 4 over 3 x plus 1 square and c is 23 over 9 x minus 2. So that's the complete decomposition, right? So we want to integrate the left hand side. Then integrating the left hand side is same as integrating the right hand side. Okay, so let me find space here because we need space to do the integration. We want to integrate x plus 1 plus, let's see, minus 5 over 9 x plus 1 plus 4 over 3 x plus 1 square and plus 23 over 9x minus 2. So we want to integrate this. Let's do the integration. Here it's easy to integrate x plus 1. If you integrate x plus 1, we can integrate these four terms separately. So integral of x plus 1 is x square over 2 plus x, right? If you integrate x, it's x square over 2. If you integrate 1, it's x. If you integrate negative 5 over 9 over x plus 1, it's negative 5 over 9 natural log x plus 1, right? Absolute value of x plus 1 plus here to integrate. So 4 over 3 comes out, that's okay. So to integrate 1 over x plus 1 square, you don't use natural log here. So actually you write it as x plus 1 to the power negative 2. So if you integrate x plus 1 to the power negative 2, you get x plus 1 to the power negative 1 over 1. Negative 2 plus 1 is negative 1, right? So that's what you get. Plus if you integrate this, 23 over 9, you get natural log absolute value of x minus 2 plus arbitrary constant c. Okay, let's finish off this nicely. So x square over 2 plus x minus 5 over 9 natural log absolute value of x plus 1. Here minus 4 over 3 x plus 1 plus 23 over 9 natural log x minus 2 plus arbitrary constant. So this is the solution for the integral. Okay, all right, so thank you very much. I will see you in the next video with a new problem. Thank you.